আর সকালে আজকে আমি আচার্য ভবনে গিয়েছিলাম। That was to me a তীর্থক্ষেত্র. So I'm really honored that I have been asked to give this talk. So let's get going. So I'm going to talk about the NASA technologies to unravel the mysteries of this universe. What kind of technology we are developing? What kind of science that we are doing at NASA? So before I start, I want to show it to you what NASA is. Most of you know. So NASA has different centers all across the United States. So our headquarters is in Washington, D.C. But I am here at Jet Propulsion Laboratory, Pasadena, California. So JPL is the largest NASA lab for robotic missions. All the missions that you hear going to Mars and going to Europa very soon, they all are done from our lab. We have about 6,000 people. And many of you know Houston. Houston, you have a problem with a big phase, right? So where we actually do about manned missions. So training facilities for all the astronauts are there in Houston. And all other centers, they have their own role to play. So of course, we are here at J.C. Bose's birth anniversary. So if you think about the contributions, you already heard from Prof. Kolkata about J.C. Bose and his contributions. So this is what he has done, the modern day communication that we all know about. Who doesn't have a smartphone in his or her pocket now? I don't think anyone, we find anyone who doesn't have a smartphone. But if you think about it, J.C. Bose actually led the way to modern communication. He was the pioneer in millimeter wave technology, wireless technology. So everything today, everything is wireless. Without wireless technology, what J.C. Bose did, we would not be here. Think about it. This smartphone that we are carrying right now, has replaced all these things. Before we used to have telephone, we used to have fax machine, we used to have camera, we used to have clock, everything, and we replaced by one single device. That was possible because of the work that Professor J.C. Bose did. And that is his legacy. So we should be all thankful to him for what he has done. So I am so fortunate that I also work in the area of millimeter wave and terahertz technology, but we are actually using some of the techniques that Professor J.C. Bose did at the beginning, 1896. He did his experiments in 1896 for wireless communication before the electrons were discovered. Think about it. So he was a little bit ahead of his time. So let's start with about some science. This is the Big Bang Theory. This is not the Big Bang Theory you watch on TV. This is the real Big Bang. We believe that our universe started with the Big Bang about 13.85 billion years ago. And currently we are here. And if you actually want to look at all this wireless communication that I was talking about, that happens using electromagnetic waves. So if you want to go back in time and try to understand that how our universe came about, what happened at the beginning of the universe, if you have to go back in time, you can go back only about 400,000 years after the Big Bang, because that is the time the first light of the universe came out. Before that, it was a big hot plasma, so nothing could come out. So actually it was discovered by two scientists, Penzias and Wilson. They were doing some millimeter wave communication experiments at AT&T Bell Labs in the late 60s, 1960s. And when they were doing some experiments and they were finding that wherever they look, they find some extra noise in their receiver. You know, on your phone sometimes you hear the hiss noise, that is the noise. So they were finding that extra noise coming. And they couldn't understand what is going on. And then they started thinking about it and they realized that what they were looking at, what they were hearing, is the first light of this universe, that is called cosmic micro-background signal. So next time, if you are, a lot of students are here, I'm really so glad to see a lot of students. So students, if you are doing some experiments in your lab, and if you cannot explain what you see, like Penzias and Wilson, don't think that it is experimental error. Because you might win the Nobel Prize, you know, because both Penzias and Wilson for their work got Nobel Prize for discovering the first light of the universe. So what do we do at NASA? That is a question that is asked often. So at NASA we do science. Yes, we develop technologies to do the science, but our main mission is to unravel the mysteries of the universe. We are trying to understand, we are trying to answer big science questions. One of the biggest science questions that we have currently is, are we alone in this universe? Is there life somewhere else outside our planet Earth? So whatever you read in the newspapers or some of the YouTube channels and all that, that aliens are found here, and they don't believe them. Because we have not found any sign of life as of today, anywhere outside our planet Earth, not even a single cell. So if someone tells you that they found an alien, please ask them to talk to us. We'll be very happy because we'll stop doing all this, spending all this money. So that will be great. Now the question is that what is the possibility, what is the probability of finding life somewhere else, some other places? So my answer to that is that there is a distinct possibility of finding life somewhere else. So why do we say that? The reason is, if you look in our sky, Calcutta is always kind of cloudy and all this smoke and smog, so you cannot see the moon really very well. But if you go out of Kolkata and go somewhere else on a dark night, you will see the Milky Way, Akash Ganga it's called, Milky Way galaxy. So in our Milky Way galaxy, we have about 100 billion stars, order of magnitude. 100 billion stands for about 10 to the power 11 zeros after 1. And in our universe, we have about 100 billion galaxies. And we are finding that many of these stars, most of these stars, they have planets. And not only one planet, they have multiple planets around them. So then what is the probability that we find one such planet in one of these trillions of planets, that conditions are such that life can exist? That has to be a finite probability. And that's what we are actually doing. So far, we have found more than 5,000 such exoplanets. They're called exoplanets. And we are looking for those planets what we call, they're in a habitable zone. Habitable zones are the places where the conditions are such that water can exist in liquid form on the surface. Why do I say that? Because when we are looking for life, we are looking for life that we need. We know our kind of life, hydrocarbon-based life, and that's what we are looking for. Because if we are looking for, someone might say that will be life of other kind. Yes, but how do you search for it? You cannot search for something that you don't know about. Rabindranath Tagore, of course, I'm a big fan of Tagore, and in any talk, anything, I try to read Tagore somehow. So Rabindranath Tagore wrote a beautiful song, and one of the lines is, Janar majhe ajanare porechi sandhan, which means that we are actually trying to find the unknown with what we know. And that's what we are trying to do when we are looking for life, because we know our kind of life, we know hydrocarbon-based of life, that's what we are looking for. So you can say that you say, right, there are trillions and trillions of planets out there, how come we found only 5,000? Because we have not really looked much. We are only looking at very narrow areas of the whole galaxy. So how do we find those planets? What is the technology that we use to find those exoplanets? One of the things we do is that suppose there is a star out there, and if you can isolate the total amount of light that is coming from that star, and if there is a planet going around, what happens is, as the planet goes in front of it, the total amount of light ever slightly dips. By measuring this change of total light that's coming in, we can say that, oh, there's a planet out there. And not only that, how much time it is going to take. From there, we can calculate what is the orbit. From there, we can say what is the mass of the star, and we can find out what is the entire volume of that. Then we can say, okay, this is the density of the star. Is it a rocky planet, or is it a gaseous planet like Jupiter? A lot of things we can learn just with this type of measurement. So we are looking for rocky planets, because gaseous planets like Jupiter cannot sustain life. We found many of them, many of those planets we already discovered. And then what we are looking for, only problem is the nearest one that we found it can sustain life. It will take about 40 million years to reach there without current technology. So we cannot really go there today. So what we are doing is developing technologies, trying to find out what we can learn more about that. As I was saying that we are looking, this is our Milky Way galaxy, we have looked only in this narrow area of our own galaxy and found 5,000 planets. So the reason is we do not have the technology. We need better sensitive receivers. We need better technologies. And that's why students who are here today, I'll ask you to join us, join NASA, and join ISRO as well, and help us developing the next generation of technology so that we can understand more. So those were the far off planets where there could be life. What about our own solar system? Is there possibility of life in our own solar system? Answer is yes. Look at this. This is Enceladus. Enceladus is a moon of Saturn. And what is happening here, what you see if you expand, water is gushing out. So this was discovered by one of the instruments called Hi-Fi instrument, or NASA's Herschel Observatory. And I was very fortunate, I actually was part of the team that developed that instrument at NASA. Then we discovered that water is gushing out from Enceladus. Enceladus is a very cold planetary body. It's all ice. If that water, liquid water is coming out, which means there has to be a source of energy in that, that's keeping it liquid. So if there is water, if there is source of energy, is there life? So what else is coming out from here? We don't know. So NASA is planning a trip to Enceladus sometimes in the near future, and we are actually developing technology, we are developing instruments to see what else is coming out. Is there any life there? That would be very exciting to find something like that. Another place is Europa. Europa is the moon of Jupiter. Again, it's a very cold planetary body, and it's thick ice. We actually, scientists believe that there is under the thick ice shell, there's a liquid water ocean. How do you know? Again, doing all these measurements sitting here, you can actually make a lot of predictions. And we believe that is this ice shell. The ice shell is thickness about 15 kilometers to 100 kilometers. So if there is a liquid water ocean, there is a mantle like our planet Earth that is keeping it liquid. Is there life in that water? So we are planning a mission to Europa. So if NASA comes to you, the students, and say, okay, we are planning a trip to Europa. So what kind of instruments you are going to send to find if there is life in that water ocean? What will be your answer? I cannot see any of you, sorry, because it's too bright, this light, or dark in front of me. So what will be your answer? Okay, obvious answer is you send a drill a hole, load a bucket and see if there is any fish. If you're in Calcutta, we all like fish, right? The problem is, it takes 7 years to go to Europa. And when we send an instrument out there, total amount of power available to us is about 300 to 400 watts. That is 3 to 4 light bulbs. How can you drill a hole of 15 kilometers to 100 kilometers through ice using 400 watts of power? It's not possible. They need to think differently. They need to come up with new ideas that how can you measure it. It turns out that what happens is there are a lot of cracks in here and the water sits all the way to the top. But since it is so cold, it freezes. But Europa is close to Jupiter, and Jupiter has a very high magnetic field, that is high radiation environment. So that radiation sputters all the materials in the atmosphere, and you can actually do high resolution spectroscopy to see what are those materials that is coming out. Is there even organics? Organics does not necessarily mean life, but that is a precursor to life. So we are sending a mission that will be launched sometime in next year. We have a lot of instruments that to actually find out what is there in terms of possibility of life in Europa. And of course, you all know that we keep going back to Mars. Recently, we have sent Perseverance, and India also had Mangalyaan mission. So why do we go back to Mars? The reason is that Mars, in its early history, resembles very much like our planet Earth. But question is, was Mars ever habitable? Was there life on Mars at any point in time? Is there life on Mars today? We don't know that answer. And that's why we are actually sending a lot of instruments. Over the years, you can see that we have sent a rover, Pathfinder in 1996, Spirit and Opportunity 2003, Curiosity 2011. Many of you know that Chandrayaan-3 was very successful. They landed on Moon, but landing on Mars is even more challenging because it takes 7 months to go to Mars. But how do we send something to Mars and how do we land something on Mars? It's extremely challenging. Let's just give you a little bit of an example of what happens. Look at this. The latest Mars mission, the Perseverance rover, was launched on, you can see here, July 30th, 2020. And at that time, things has to be aligned perfectly. You can launch to Mars only once in 2 years. That's when the distance between Mars and our planet Earth is the least. So it was when it was launched, Mars was here. As you can see, Mars is going around on this orbit. And then when it's launched, this is the spacecraft, it has to be arriving here at this point at the right time. Because just before Mars comes here, we have to arrive at that point. And then the cruising speed of our spacecraft is about 77,000 kilometers per hour. It's a huge number. With that speed, we cannot really enter in the Martian gravity field. So you have to slow down. We slow down to about 20,000 kilometers per hour at this point when we are here. And as Mars comes from behind and catches up, we insert it in Martian orbit. And then what happens is, you can see here, this happened just before Mars came. We actually were there, and we are slowing down, and Mars came. We actually entered in the Martian gravity field, and that is not enough. Then Mars atmosphere is just 1%. The density of Martian atmosphere is 1% of our planet Earth. So it does not slow down that easily. The friction is not enough. So we'll have to enter at a very particular angle, about 11 degrees, and so that it gets maximum friction. And then as it's going down, we launch a parachute. But parachute we generally don't launch at very high speed because it will break. But we don't have any options. We have to do a lot of experiments. Mojave Desert, very close to California where we live, we are doing experiments to make sure that the parachutes work. They are big parachute, and then slowly it goes down. But we'll have to still then use some thrusters to slow us down even further. And then when the thruster comes, problem is, if you keep on using the thruster and you go very close to the ground, Mars has a lot of dust and stones on the ground. They'll all come up and destroy our instrument. So we cannot do that. So we are scratching our head. How can we do that? What we need to do? We came up with an idea of using a sky crane. Think about it, it's so crazy. Just who uses a crane on another planet from a spacecraft? But that was the only option we had. And when someone came up with this idea, we thought, no, it might not work. Then we did the experiments and said, yes, let's go for it. And we were successful. Then the crane slowly lowers the spacecraft on the ground, and this spacecraft, this thruster, they fly away so that it doesn't fall on the instrument, on the rover. And that's how we land. And this is the Perseverance rover. Just before it was sent to Cape Canaveral for launch in our lab. If you come and visit us at JPL, I'll show you this lab. This is a huge facility where we actually put everything together. This is a clean room, huge clean room. This is where we actually put everything together. And look at this. Look at this, all these pictures. If I tell you these pictures from here on planet Earth, you might believe But no, they're all from Mars. These are pictures taken by different rovers on Mars. Look at this. I can say that this is one of the roads in the monsoon in Kolkata. But if you look at the terrain, here we get this kind of terrain only when there is flowing water. You can get this kind of terrain only when flowing water. Which means at one point of time on Mars there is flowing water. But if we go there today, we don't see flowing water. The question is, what happened? Where did the water go? Can it happen to us on our planet Earth? What can you do to prevent it? So these are very important questions. A lot of people ask, why are we spending so much money to send something to Mars? People are hungry on our planet, but we have big problems to solve. And these are one of those big questions that we have. And as I was talking about water is very important for life. And it turns out that, is there enough water in the universe? That was the question. So that there can be life outside? The question is yes. It's a very interesting story that we found, using again the Herschel hi-fi instrument that I was involved in, that we found that from very young stars, water molecules are coming out at very high speed, 200,000 kilometers per hour. If you fire a bullet from AK-47 rifle, the speed of that is only 2,500 kilometers per hour. So these water molecules are coming out at 80 times faster. And they find a way to recombine, and then total amount, we are finding that total amount of water in the Amazon River is being produced per second in one of these plants. So we have huge water. The universe is flooded in water. We have enough water. Maybe there will be life there. Water is very interesting because when Earth was formed, there was no water on Earth. Did you all know? Scientists believe that comets brought water to Earth. Comets carry a lot of water. But we have not proven it 100%. We have measured only about 10 to 12 measurements we did. So the question is, how do you prove that comets brought water to Earth? So as a student, you should always ask questions. Because if someone says, okay, comets brought water to Earth, you say, how do you prove? How do you know? How do you know is that it turns out water has different kinds of water up there. The water that we drink every day, that is H216O. Oxygen has different isotopes, 16 is one of the most stable isotopes. So that is most stable water. But the other kinds of water, H217O, H218O, HDO, one hydrogen, one deuterium, and one oxygen also makes water. And if you take the ratio of abundance, how much of different kinds of water is there on planet Earth, they match very closely with some of the comets. They are called Jupiter family comets. So we are actually building instruments to answer that for once and all, if comets brought water to Earth. I will talk a little bit about that technology later on. So we also did a lot of other technology. Most recently, you must have heard that we went to an asteroid, collected some materials and brought it back to Earth. How interesting is that? So we did that called NASA's OSIRIS-REx, and that was launched in 2016. Only recently got this material, and you can see this is that asteroid. We took a very close picture of that, and we collected some of the materials. This is the size of that, and that one is actually in between Earth and Venus. The asteroid was. And this is the actual material that we have collected. This is very interesting. This is the first time we actually got some materials from another asteroid. Why it is important? Because looking at them, we will be able to understand how our planets were formed at the beginning of the universe. So we have just started analyzing it because it is very recent. Last month we got this material. Another thing many of you know, that we actually launched something of a mission called Psyche that is going to one of the asteroids. It's a completely metal asteroid. It has metal of iron and nickel. It's very, very exciting. And what happened is, this was like our own planet at one point of time, but a lot of asteroids and other materials hit that, and then lost all its top core, top layer, and what is left is just the metal core. And we are sending something, this one is in between Jupiter and Mars. So it will take a long time for us to go there and study this particular asteroid. But recently you heard that we did, last week there was in the news, that we did we did the longest laser communication. Because we had an experiment of laser communication. In the future, we are trying to increase the bandwidth so that we can send more data. And we did the laser communication for the first time. It is actually 80 times, distance is 80 times more than the distance from Earth and Moon. So that's what we did. So and also we are using electric propulsion for the first time for this mission. So that will be very, very exciting as well. So another thing, of course, I tell you that oftentimes you read fake news on WhatsApp that one asteroid is going to hit planet Earth, is all going to get destroyed. And whenever there is fake news, you realize they write, NASA said that. As if NASA says it's all true. That actually puts a lot of pressure on us because we have to make sure that whatever we say is all correct 100%. So here, we actually are tracking a lot of asteroids and trying to find out, are they going to come and hit us? Are they going to destroy us? So that is recently we did a mission called DART mission. I'll tell you a little bit about it. And if you look at that, there are a lot of asteroids, we track them and they can come and hit us. Well, most of them are very small, like 25 meters of size. If you look at them, there are possibility of they coming and hitting us about once in 100 years. They're small, and the damage they will do a little bit. There will be some. Most of them will burn because of the size in the atmosphere. So not much damage going to do. But if there is a bigger one, 140 size, they come here about once in 20,000 years, and then we have found about 39% of them, about 25,000 of them are there. So you can actually keep track of them. So one of the big ones coming and hitting us, the probability is extremely low. So next time you read a WhatsApp message that something is coming on our way and tomorrow our Earth will be destroyed, don't believe it. And don't send me a WhatsApp message asking, is it true? All my friends do that. So it is not happening. However, for that, we are prepared. We are preparing ourselves. NASA did a mission of DART. There is 2 asteroids you can go in called Didymos is the big one, and the small one is going around it. So what we did in this DART mission, we sent a spacecraft and hit it directly off one of the smaller asteroids and change the orbit of that. So that was the idea. Can we send a spacecraft, hit an asteroid, and change the orbit so that it will come and hit us? So that's what we wanted to do. And you can see that this mission was about 570 kilograms, and this is the bigger one, this is the size. We wanted to hit this one, 163 meters of diameter. And as it was going close and close, we actually took a lot of good pictures. You can see this is how it looks like. So this is the beauty of all this, that when you look at this asteroid, how closely they resemble our own planet. So you can see here all these stones. And what happened is we hit the good side. It is not easy to go and hit a small asteroid in far places, but we did that. And originally the orbit of that asteroid was 11 hours and 55 minutes, and after we hit that, the orbit time changed to 11 hours and 23 minutes. We confirm that, and that is enough to move an asteroid away from us. So now we have technology. In future, if something is really coming on our way, we will be able to move it away. And recently, we are also using a lot of new technologies, something called CubeSat. I can see Satyajit is sitting here. He's from IEEE, and I think Rajeshri is also sitting here. So they have been working in their college with the students developing some of the technologies. So in NASA, as well as other space pose a lot of challenges because how do you fit everything in such a small volume? So we have done what sent 2 CubeSats to Mars for communication purposes on Mars. That was the first time we used a CubeSat to have a relay station, because as the spacecraft goes down on Mars, we do not have a direct communication for about 10 minutes. So to avoid that, we actually did that. You can see here animation how the CubeSat, the small CubeSat are thrown out from the main mission. They just throw us out, and then you can see here, then we go out, and this is what the Marco that I mentioned, and you can see the CubeSat has their own solar panels. They deploy, and this is an antenna. It's called reflector antenna. Some people who actually work in this area, they know the reflector is a foldable reflector antenna that it will deploy and do the communication. So that's what we did. You can see here the other one is coming out, and this is what we deploy. I'll show that to you when it deploys. You can see these antennas. These are the antennas actually. And these antennas, what they are doing is, you have a flat surface that electrically makes a parabola. So effectively, electrically make a parabola so that you can do some communication. So that's what we are doing here. And as the spacecraft goes down, and it communicates directly with these CubeSats, and they send the data back. So that's how we get this done. So we are making a lot of instruments in this small volume of CubeSats. You can see here, this is called radar instrument that we have built. It's called RAIN Cube. So this is again a small spacecraft this size, but we have to put a 50 centimeter antenna in that. The question was, how do you put a 50 centimeter antenna in a very such small volume so that it can deploy and then you gather all the data? So here you can see that this is the antenna when it's deployed. So that I'll show you how this thing is deployed. Can someone click on that? If you can click on that picture. There's a video there. There's a mouse there. You can just click.
Just a click.
Yeah, there's a mouse there. Yeah, you should just click there. Yes, just click. You can see this is how it is deployed. There is a spring-loaded structure, and this is a Ka-band. People who know Ka-band is about 30 gigahertz. It's not easy to make this kind of antennas at this frequencies. This is a millimeter wave. Again, you can see most of this more kind of frequency band. And you can see here the antenna is deployed, and there will be a sub-reflector deploying again, and then the communication happens. This is a beautiful way of deploying mechanism. So what I'm trying to show here, that it is not about one person doing design and implementation. I have to work with the electromagnetic engineer, we have to work with the mechanical engineer, we have to work with the thermal engineer, so that everything comes together. So teamwork is the key for success. So always keep that in mind, the student. So I was mentioning that we have developed a new technology for CubeSat based, but we do not know about that whether comets plot water to water. We have not proven it 100%. So I actually developed, I wrote a proposal to NASA, and I call it WhatsApp. The name of the instrument is called WhatsApp because it is water hunting advanced terahertz spectrometer on ultra small platform, because we are trying to answer the question, what's up with water? And in that, this is very small volume instrument that we are trying to do. This is the block diagram, because as I said, there are different kinds of water. You can see here I list different kinds of water and their frequencies. So this is the instrument trying to detect all those high resolution spectroscopy that we are trying to do. So many of you are here, the students. One of the things that you have to realize, you have to really think about, how do we start doing it when we are trying to answer a science question? How do we go about it? What is the process? So I will explain a little bit. What happens is, we are trying to answer a big question. It starts with a science question, like, did comet plot water to water? This is the science question we are trying to answer. The next question will be, to answer that science question, what kind of measurements we can do? As I said, one of the measurements we can do is measure different kinds of water. The next question will be, to do those measurements, what kind of instruments that we need? What kind of frequencies we are going to choose? And then next will be, what are the technology gaps we have? Which means what is not available today that we need to develop so that I can build that instrument. That will do the measurement. That will answer the science question. So this is how all this is done together for NASA. So we build some antennas. You can see the 550 gigahertz actually. There are extremely difficult to make this kind of antennas. And we build some lens antennas as well. And we also build some of the switches. You know, what happens is as you go higher frequencies, millimeter waves only coming to fruition today. Nowadays, people are starting working on millimeter waves. Even there, we don't have low frequency instrument that we have, components we have not available, like a switch. Electromagnetic switch is not available like lower frequency. We actually build a lot of new technology. We have a lot of patent on this, that how we can make these kind of switches using waveguides. And this is a patented new technology that we developed in our lab, where we can actually move some waveguide structure in piezoelectric motors. It's very tiny motor that moves things and they build switches. And also we are using the technology of cell phone technology that we call it. You know, semiconductor technology that is available in your phone. If we say what we need to do, if you try to send your iPhone to space, it won't last even a millisecond. It will be destroyed. Why? Because our space is a very harsh environment, a lot of radiation out there. So we are developing our own semiconductor-based cell phone kind of technology that can be sent to space. We have done that in our lab, and this is the instrument that we put together. This is a WhatsApp instrument that I was talking about. You can see here all this came together, and this is how tiny the instrument is. You can see this is in our lab. The entire instrument is here. I'm standing there to just show the size of this. Kind of show of size, this size instrument. And then we wanted to fly it on a balloon to do some experiments. There is a place in US near New Mexico called Fort Sumner. And there is a place is very close to Roswell. If you do a Google search of Roswell, you'll find that people in Roswell believe the first alien landed there. And since we are sending a balloon mission to test it out, we put our own alien, we call it Bob the alien, on our balloon payload, so that when people in Roswell finds it, where the balloon lands there, they will find another alien. That is why we did that. It is very successful. Right now, we are waiting to get a ride. So in future, we are building multiple copies of these instruments. So when we, in future, you saw that we are actually throwing it out on the main mission, you can send this through this small instrument. And as suppose we are going to Mars, you throw us out of the way, and then we go to all these comets and do the measurement and answer for once and all. So I'll take next 5 minutes and show you something else, and then I'll end. I want to give more time for question and answer. Many of you know that when we launched this Perseverance rover, we also had a helicopter called Ingenuity helicopter. This is the helicopter that is shown here, getting final data before it's mounted. So the question is, why helicopter to Mars? The reason is that we send a rover, but the rover has limited mobility. It cannot go anywhere to do all the science experiments. So if you have something, a helicopter or a drone, whatever you want to call it, it can take off, go around, do reconnaissance, and send the data back to the rover, and then the rover can go and do further experiments. You can do that. So what is the problem? You can see helicopter flying on our skies all the time. So then what is the problem in flying a helicopter on Mars? The reason is Mars atmosphere, as I said, is 1%. The density of Mars atmosphere is 1% of planet Earth, which means there is not enough lift for the helicopter to actually fly. So when we fly helicopter on our planet Earth, the blades rotate at 600 RPM, revolution per minute. But for Mars, it has to rotate at 2,500 to 3,000 RPM. It's a very, very challenging environment. So this is a self-sustaining, we want call it a tech demo, technology demonstration. It's basically autonomous vehicle. It takes off on its own and flies and goes there. And NASA said, okay, you can have 3 to 4 flights maximum, because it's not going to survive perhaps. So it will be about 2 to 3 minutes duration maximum. It will go height about 40 meters or so, that's all. Just whether it works or not. So we put everything together. So the instrument was mounted under the belly of the Perseverance rover. You can see these are the pictures taken by the rover itself. The rover has a camera and it took all this photograph. You can see here the cover was dropped first and slowly the helicopter was lowered down on the ground. These are real photographs. These are not animation. They are real photographs from Mars. And you can see here that the helicopter was put down. And then you can see that helicopter for the first time on its own. And these are the track marks of the rover that moved away. And the rover took the photograph, you can see here, about 40-meter distance from the helicopter. I was standing there and taking these videos. So I'll show you the first flight of this. So this is the first flight of that helicopter that happened in 2021. And there was a camera mounted on the helicopter, and you can see here, this is the shadow of the helicopter as the helicopter taking off. And so you cannot see here is the real altimeter data of that. So basically the idea was that helicopter will fly for about 40 seconds. It will go about 10 feet, about 3 meters up, and make a 93-degree turn and then come down. That was the first demonstration, because we have never flown anything on another planet before. So that was very, very challenging. And this is you can see here, the very first flight. And this video was taken by the Perseverance rover. You can see here the blades are moving. And then the helicopter took off. And it will make a 93 degrees turn. People ask, why 93 degrees? We say, why not? Any degrees will be fast. You can see here it turned. And then it come down at the same spot. So that was amazing. It was really some big achievement. And as I said, that we wanted to have 3 to 4 flights. As of today, we have made 66 flights of this helicopter. We are trying to break this instrument. We are trying to fly as fast as possible. We are trying to go as high as possible. We are trying to go as far as possible and trying to see when it will break. But this small thing is not breaking down. So NASA has extended the mission of this life. So this is what I am going to end here. And thank you very much.